Guys, welcome back. So I'm rigging up some new type of commutator or switching circuit for the Newman motor. I 3D printed this odd looking thing that has a spring action for like points. I'll run some wires in there and connect them to two opposite sides. And then I have a cam right there. So it'll run, the cam will hit it, and it will close the points and make the connection. I also 3D printed this guy, which I will put a magnet on this side connected to a wire that goes down and a copper plate on the opposite side, and I will run it either here to see if the magnet can pull it close, to pull it close like that, or I'll run a ring. Oh, that's what I need to do. I need to 3D print some sort of ring to hold the magnet, because that was my original thought, was I'd have some sort of ring here with a magnet on it, and this would obviously be up higher, and as the magnet went around, it would pull the contact closed like that. So I don't know how successful any of these will be, but we're going to give it a go. So stay tuned. So interesting. I've never had much luck soldering wire to copper like this, but I got this Circuit Works flux, and this stuff works great. 3220. It works better than any flux I've ever had. And that thing is securely connected to there, because I was trying to figure out how am I going to connect it to the, well, anyway, you guys will see where I'm going with this. I just wanted to share that with you because I was able to do that within a second, and I couldn't believe it. Anyway, stay tuned. So what a pain in the ass this was, but it works. I 3D printed these channels in here for the wire, and then one out the back. So not the prettiest thing, but it will work. I'll check continuity here in a second, but I'm pretty sure it'll work. So I'll try this one first, and then I'll get a tiny magnet, and let me glue the magnet onto that so it'll get a chance to dry while I'm playing with this guy. And then I have to mount this underneath the cam in such a way that it, oh yeah, I may have to move the cam. In fact, I know I'm going to have to move the cam about a ½ inch down, because the way this is set up, the commutator, the connection to the commutator is facing this pole. I don't know what pole it is. And by the time it gets parallel and it hits the wire, it makes the connection and causes it to either pull or push depending on the pole. This is going to have to hit it. Yeah, so I'm going to have to actually turn it a lot more. I'm going to have to actually turn it a full 90 degrees. All right, stay tuned. All right, so it works. It's kind of cool, completely 3D printed. It's a little noisy, but it does work. So I'm still using the same connector back there that I really like. That's like going to be my universal connector now. I don't know if you could see the sparks. Yeah, it's cool, but I'm not that fond of it. I'll have to tweak it so I can get it to go faster, but it's working. That's all I wanted to do is just to, it's starting to speed up now. I don't know why. It's at 12 volts. It's kind of cool. All right, let me get the magnet one set up. I've already glued a magnet to it. So I got to set the wires up for that one. And it turns out that this magnet is definitely strong enough that if I mounted it right here, I don't know that if the spot right here is going to be okay, or if I have to move it up or even up here, but we'll find out. But yeah, that guy works pretty good. A little noisy, but it is a cam, so. All right, let me switch it out for the other one. Stay tuned. So really quick, I moved the cam a few, like a centimeter in either direction, and it doesn't seem to change the speed. So this is moving maybe 5 millimeters in that direction, and I tried it going in the other way. Because the way I started off, it was 90 degrees from vertical from the rotor, which is exactly where the commutator is set up, or it's 90 degrees from where the commutator is set up. Something oddly satisfying about this setup, but let me switch it out. Stay tuned. All right, so I got the magnet wheel, which is going to spin around, and I've got the magnet with the copper on one side, the copper facing away from the back. I've got that being crazy glued in place. Of course, the copper side won't have any crazy glue on it, or the side facing the contact. And then I'm just going to, because I was smart enough to, or not smart enough, I was lucky enough to pre-drill a hole in the back of this, I'm just going to put a screw in there for the contact. So it'll go like that. Yeah. And everything else is already all set up. I just need to run, I just need to run this guy off of that, and then run the black line off of that into the back of this. Anyway, yeah. Couple more seconds, crazy glue should be dry. I should have this thing going. Stay tuned. All right, so I got it all set up. You can see this is the magnet end that pulsates back and forth. I don't know if you can see that. And there's the magnet. Goes around, connects to this guy. Well, it doesn't connect to that guy, but let's see how it works. Ooh, self-starter. Working pretty good. A lot better than the other one. A lot faster too, much quieter. That's pretty cool. Can't really see any sparks though. Not that I want to see sparks. Keep the top on. Yeah, that's going much faster than the one that had this guy here. And I'm still using this for the main shaft. I'm gonna be using that always. So let's turn it up. This is at 12 volts. There's 14. There's 16. really quiet. There's 21. Now you can see some sparks. Because a lot of current's going through this. Turn it back down. Yeah, 12 volts is good. What I want to do now is with this setup, I want to hook it up to the super cap. But I like this one. It's nice and quiet. It's actually much quieter than the commutator itself. Why is it slowing down? Yes. Okay, dinner's on. Why is it slowing down? What happened? Have to investigate that after dinner. Stay tuned. Yeah, it was just a loose contact or something. I don't know. But now it's back to running full strength. Really quick, too. 12.7 volts. Oh, I apologize for that exit before going to have dinner. Yeah, I kind of like this. I got to make it better, though, because I need to print it with a hole that comes up. A hole that comes up the back there for that side. And then I got to figure out a better way to do that guy, even though it's working really well. I forgot how much I like this Newman motor. It's pretty big too. I was thinking about printing out a really, really big one and do it in segments, but I don't know. I'm going to see if I can't turn the commutator a little bit. See if I can't get a faster speed, although I think this is probably it. Nice and quiet. Spinning much faster than what the camera is picking up. The camera makes it look like it's going slow, but she's flying. I gotta figure out a way to pop that off like that so it's not hitting. Oh, anyway. Yeah, I was worried about that for a second there. It was just this guy was loose or something. I forgot what it was. I just pressed on it and started it back up again. All right, let me see what else I can come up with for you guys. Stay tuned. All right, so there it is, using this guy running on the super cap. Oh, I see what's going on there. I'm losing one of the wires there. Let me fix this up. But anyway, it's running on the super cap, and I think the super cap is down. So stay tuned. So the super cap's got 8 volts on it. Which is a good enough to get this guy going and keep it going. There it goes. Anyway, let me figure out some more stuff, and I'll see you on the next. I'll see you in a little bit. Stay tuned. So this is interesting. This is a Hall sensor, or a Hall, sensor circuit, and the Hall sensor is way out here, and it shows how powerful this magnet is, or the magnets of the Newman motor. Yeah, it likes it way down here. And it's spinning at a decent clip too. So we tried the dual JL94 circuit. That works obviously great because I can hook it to both coils independently of each other, and it works like a dual, like a bifilar, coil. I've tried the regular commutator. Kind of wicked sound. I've tried the magnetic commutator, the one that springs back and forth, and I've also tried the one that goes up and down like this. They're basically exactly the same. And now I've tried one of my Sky Hall circuits. This one's got the timer on it. And someone made a comment that because I have this neon bulb and an output, the neon bulb shouldn't be going on if I have the output going to a regular bulb. But I think because the spikes are so large, it's going to still affect the neon bulb. Everything's nice and cool though, which is good, including the circuit. All right, let's try some different circuits, some different Hall circuits or some other ones. Stay tuned. So here we go. This is a regular run-of-the-mill Bedini circuit. Not run-of-the-mill, it's a very nice circuit. But it's flying, and so I have it set up the way you would normally set up a Bedini system. We've got a trigger and a primary, right? We've got a primary power in and a charge, which is going to the light here. And if I turn the potentiometer just so slightly, it turns off so I have to have it all the way on. I'm trying to do it so that it turns off the... Yep, no. Because this is not ideal for a Bedini circuit, but it works and it's got great output. For me, it's almost solid. And it's flying. 12.5 volts. I think that's... Yeah. So that's pretty cool. I happened to catch this circuit out of the corner of my eye. I said, I wonder what that looks like on a Newman motor. I should play around with the way the coils are triggered. If you guys got any ideas, let me know. Because right now it's set up the way a normal Bedini system is set up. One trigger, one primary. Or one run. One trigger and one run. Yeah, I don't know where I'm getting this word primary from. Yeah, trigger and run. I should have made that an R. I suppose I could switch them. Right now, the top is the top. No, right now the bottom one is the trigger coil and the top one is the run. Let's see what happens when I switch them out. Stay tuned. So I switched them. Now this is the trigger and this is the run. That actually seems to work a little bit better. Better in every way. Higher speed. I could just be imagining things. You guys let me know. Is this faster? The output seems to be a little bit stronger. Yikes. Better keep that top on, man. I mean, I think I'm okay, but I've been warned. Yeah, everything is still really cool. Yeah, cool. Let me see what other circuits I have. Stay tuned. All right, so this is that great circuit that I screwed up on day one. It works really good. It's a Hall circuit, but it had a readout here. And it's the readout. Watch. You'll see the blue smoke coming out. Yeah, it's the readout that's burnt out. So it also burnt out the back EMF 1 channel. So I have to trace it in there and see if I can order another one of these. I don't know why it would mess up the back EMF 1 channel though, because it's just this guy that's shot. But it still works great. That's why I set it up, just to show you that it still works great on this very peculiar setup for it. All right, stay tuned. And then of course the insanity with this super as high speed, holy shit, with the dual JL94 circuit. Freaking output is screaming. And this guy is screaming. Oh, I better shut it down. Yeah, this is the winner by a long shot. I don't care if the magnets come flying off and hit my phone. By the way, I'm well enough away from it in case they did come apart. Yeah. So it's pulsating on the camera, but for me it is solid. Let me turn this off. Ay, ay, ay. Yeah, that's the creme de la creme of the craziness. Anyway, thanks for watching, guys. Ciao. So this is running off the super cap, charged up to 12 volts. Remember, these 6 super caps are 500 farads each. And yeah, I got to figure out a way where I could put a speed controller on that, because it is flying, dangerously so. I mean, you can hear it. So the super caps are running great. I didn't know how well they would run this circuit. So you can see it branches off on either side. So I could actually run one side or the other side, but running them both in a bifilar type coil situation where I've got this coil hooked to this side and this coil hooked to this side. Yes, yes, yes. I could not leave without trying it with the super cap. Here, let's see what it looks like without the top. Ay, ay, ay. Let me unhook this bad boy. Oh, now it's really chow for good. Thanks for watching. Bye-bye.